Hello dear viewer, and welcome to the second of the two-part video regarding special products. This is Jason Bogain to help you through your mathematics ventures. We have already discussed the definition of special products and the different special products involving squares. Thus, we will proceed with something a bit more complicated: cubes. If you are not yet aware of cube numbers such as 2 cubed, which is equal to 8, or 3 cubed, which is equal to 27, and whatnot, then I suggest you read, or better yet, watch some references regarding that. Meanwhile, if you missed the first video, it is linked through the description box or is shown above. Once you're ready, feel free to come back to this video. Without further ado, the next type of special product is the cube of a binomial. Remember that if we have a cube, then a number or a set of terms is raised to an exponent of 3. That means writing a number 3 times and getting their product. The cube of a binomial, in the form x plus y cube, is a special product where the binomial x plus y is multiplied by itself 3 times. Basically, if we have x plus y cubed, we should have x plus y times x plus y times x plus y. From the square of a binomial, we were able to obtain x squared plus 2xy plus y squared. If we multiply this with another x plus y, we will have the cube of the binomial. Simply said, we just have to multiply the square with another binomial. And with that said, FOIL is no longer applicable here, so the usage of the distributive law of multiplication is important. Right now, let's try to multiply x squared plus 2xy plus y squared and x plus y. According to the distributive law, we have to individually multiply the terms. That is, we are guided by the lines and the colors. The first are the first terms, x squared and x. If we multiply them, we have x cubed. 2xy times x will be 2x squared y, and y squared times x will be equal to xy squared. If you are confused as to how these work, recall the laws of exponents and multiplication of variables. Now, we have multiplied the trinomial with x, and the product was x cubed plus 2x squared y plus xy squared. However, notice that we have only multiplied it with x and not yet with y. Therefore, we still have to multiply that trinomial individually with y. This is why this is so complicated. But it is a special product for a reason, and we will be revealing that later with a technique. Now let's multiply all of them with y. X squared times y is equal to x squared y. 2xy times y will be equal to 2xy squared, while y squared times y is y cubed. I hope you understood that. Thus, our product with y would be x squared y plus 2xy squared plus y cubed. Now that we have obtained our products with x and y, we just have to add all of them together. We should then have x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. This looks long, but if you have good observational skills, then you would know that this is not our final answer. If you observe carefully, x cubed can no longer be simplified, so we just have to copy that. However, for the second term, we have 2x squared y, which is similar to x squared y. Remember that x squared y has an invisible coefficient of 1. Therefore, if we add them, we should have 2x squared y plus 1x squared y, which would be equal to 3x squared y. The same goes for the third term. We have xy squared, which is similar to 2xy squared. Meaning, if we add them, we will have 3xy squared, and the final term y cubed can no longer be simplified as well. So we just have to copy that. This then becomes our final product. x cubed plus 3x squared y plus 3xy squared plus y cubed. But like the square of a difference, we also have the cube of a difference. Much like the square of a difference, instead of a plus sign, we have a minus in the middle. Therefore, we would have x minus y times x minus y times another x minus y. Like the process of the cube of a sum, let's get right to it. We have already evaluated the square of a binomial, which is equal to x squared minus 2xy plus y squared. If we were to expand this to a cube, we just have to multiply x minus y into this trinomial. By doing so, we have to use the distributive law once more to expand this. Similar to the process of the cube of a sum, we have to multiply them individually. Once again, be guided by the color coding to make everything easier. X squared times x will be equal to x cubed. Negative 2xy times x will be equal to negative 2x squared y, and y squared times x will be equal to xy squared. Adding them all together, we should have x cubed minus 2x squared y plus xy squared. What about with negative y? Remember that signs are very important in this process. With negative y, we should have x squared times negative y, which is then equal to negative x squared y. Meanwhile, negative 2xy times negative y will be equal to positive 2xy squared. Remember that the product of factors with the same sign is always positive. Meanwhile, y squared times negative y will be equal to negative y cubed. And after doing so, we should have the product with y, which is equal to negative x squared y plus 2xy squared minus y cubed. Adding all of this with the product of x, we should have x cubed minus 2x squared y plus xy squared minus x squared y plus 2xy squared minus y cubed. Again, simplify what can be simplified. Copy x cubed because it can no longer be simplified further. The second term, negative 2x squared y, is similar to the fourth term, negative x squared y, which means if we add them, since they are both negatives, we would have negative 3x squared y. The same goes for the third term, xy squared added to the fifth term, 2xy squared. We should have 3xy squared. And lastly, copy the last term, negative y cubed. This is our final product. Now, compare the two cubes of a binomial. Notice that the only difference between the two would be the signs. If the original expression had a plus sign between them, then all of the signs in the products are also plus. But if we had a minus sign, then the signs are alternating. Plus, minus, or positive, negative, and positive, negative. Here comes the technique. Instead of reading all of these individually, let's get right into the implementation. Our example here is quantity 8 minus j cubed. The terms here are 8 and j, obviously, and the first step is to simply cube the first term, which is 8. If we cube 8, we should have 8 times 8 times 8 equal to 512. The next step is to square the first term and multiply the second term. That would then be 8 squared times j. 8 squared is 64 times j equaling to 64j. The next step is to multiply the product from step 2 by 3. Basically, 3 times 64j, which is equal to 192j. This 192j will become our second term for the product. The next is to multiply the first term to the square of the second term. This would mean we have to copy the first term, which is 8, then square j. Multiplying them together, we should have 8j squared. But like the third step, we have to multiply this product by 3 in the fifth step. 8j squared times 3 will be equal to 24j squared, and this will be our third term for the product. The next is to simply cube the second term. Now we have all of these terms, but what signs do we put in them? For step 7, look at the sign in the middle of the original expression. Minus, right? Then according to the step, put alternating signs if the original was minus. Therefore, we would have plus 512 minus 192j plus 24j squared minus j cubed. This could be our final answer, but we should follow the standards. Step 8. Rearrange according to power. The power with the highest degree is j cubed. However, it has a negative sign. Putting a negative sign as the first term doesn't look quite nice. So let's have the second highest degree, which is positive 24j squared. Then we can have minus j cubed, with the next being minus 192j and 512 since it has a variable with degree 0. This would then be the final product. The considerations in the arrangement are degree, sign, and alphabetic order. I am hoping that you were able to follow suit because we will be proceeding to the last special product. The last special product is the sum and difference of two cubes. This special product is quite special, to say the least. Instead of being given the factors, we are given the expanded form because it is easier to look at this way. Oftentimes, you will be asked to find the factors instead of the product itself, but of course, the reverse may also be asked of you. The expanded form in this case is in the form of x cubed plus y cubed, or it may also be x cubed minus y cubed. See? It looks easier this way. But let's test out the sum first. I am expecting that you already know the distributive law. Thus, I will be giving you the factored form immediately. If you want to verify if this is true, I will give you 5 seconds to pause the video at this very moment and proceed once you have an answer to check. Let's proceed. With the distributive law, let's try to expand this. Once again, to make matters easier, color coding is provided. X times x squared will be x cubed, x times negative xy will be equal to negative x squared y, x times y squared will be equal to xy squared. Then we have with y times x squared which will be equal to x squared y times negative xy which will be equal to negative xy squared, and y times y squared will be equal to y cubed. By this time, we will be simplifying what can be simplified. The second term, negative x squared y, can be added to x squared y, and since they have opposite signs, we can cancel it out. The same goes for xy squared and negative xy squared. What do we have left? We have x cubed plus y cubed, confirming our assumptions that the factored form and the expanded form are equal. But what about when we have a difference instead of a sum? I am providing you with the expanded form and the factored form once more, so try it out like earlier. We have here x times x squared, which is equal to x cubed, x times xy, which is equal to x squared y, x times y squared, which is equal to xy squared. Next, we have with negative y. We have negative y times x squared, which is equal to negative x squared y, negative y times xy, which is equal to negative xy squared, and negative y times y squared, which is equal to negative y cubed. Right here, we can cancel out x squared y minus x squared y and xy squared minus xy squared, leaving us with x cubed minus y cubed, once again confirming the assumption that these two are equal. Comparing the products, we can see that the only difference between the two is that for the first factor, it copies the original sign, while for the second factor, the middle sign is the opposite of the original. With this, we have a technique. Like earlier, let's no longer read these individually and immediately try to solve an example. Our example here is O cubed minus 64. The very first step is to extract the cube root of the two terms and copy the sign in the middle. We have o cubed and 64, and if we extract the cube root of both, we would have o minus 4, since minus was the original sign. By extracting the cube roots, we would be made aware of what the original terms are. Those are o and 4, so let's take note of that. The next step is to just enclose it in parentheses to signify that this is a factor. You can incorporate this with step 1 to make the process easier as well. The third step is to square the two terms and add. We have o and 4. Therefore, the squares are o squared and 16, and adding them, we have o squared plus 16. Next is to find the product of the two terms and reverse the sign from the original. So we have a minus from the original, we should have a plus in this step. Finding the product of the two terms, we have plus 4o, and we will just be adding this to what we have found in step 3. That would be o squared plus 16 plus 4o. But then, we can reorganize according to power, so that would be o squared plus 4o plus 16. And lastly, enclose these in parentheses as well. After that, we would just need to multiply the two found factors. This would then be our final answer. The factored form of o cubed minus 64 is o minus 4 times quantity o squared plus 4o plus 16. And that's it for the last special product. As I've said, the special products involving cubes are more complicated, but these will be very important for your future mathematical ventures. To summarize all of these processes, I will be showing the types of special products involving cubes and the steps in solving them, and I will be showing them for 10 seconds each, so keep an eye out for that. If you wish to test your skills, an evaluation sheet through Google Forms has been created and is linked through the description box below. Meanwhile, another link is made for your practice sheets in case you want to practice further with the key to correct answers provided. That would be all from me, and once again, good luck on your mathematical ventures. Don't forget to like and subscribe to our channel. Meanwhile, type in the comments your suggestions and questions. See you next time and happy learning!